Till now, we have covered the definition of antenna, various applications associated with it, and the wireless communication block diagram as well. We all know that antenna operates at a certain frequency, and that certain frequency belongs to varying range frequency, which is known as electromagnetic spectrum. That electromagnetic spectrum consists of extremely low frequency to extremely high frequency, which is known as exahertz. So basically, in the electromagnetic spectrum, we are having ELF, which is known as extremely low frequency, then very low frequency, which is followed by this low frequency, medium frequency, high frequency, very high frequency, ultra high frequency as well. And then moving on to further, we are having super high frequency, extremely high frequency, and then coming with the millimeter wave band, which belongs to some 30 gigahertz to 300 gigahertz. And after that, we are having terahertz, petahertz band, and exahertz, which is the most high frequency in the electromagnetic spectrum. We all have studied about one of the formula which stands for F is equals to C by lambda, where F corresponds to frequency, C corresponds to the speed of light, and lambda correspond to the wavelength. So here, if you look the curve which is going on, and just below the petahertz or terahertz band, it started reducing. It's nothing but the wavelength. Basically, at lower frequency, the wavelength is large, which means the waves can travel for a long distance. But in case as we move up to high frequency, the wavelengths becomes shorter and shorter. Since by the formula, we can easily observe that frequency is inversely proportional to the wavelength, which means at high frequency, the wavelength will be shorter and shorter, and hence the communication will be more complex. And correspondingly, as per the frequency range, we are having applications based on that, such as the earth and subways. Subways, we all might remember that subways are used as a transportation, and we are having CRT monitors, which is cathode ray tube monitors, which is having a very big box like structure, and behind the monitor it seems so it all work in region of very low frequency or extremely low frequency. And then further, we are having some wireless TV, having some two antenna string uh, set up on its top. And then we are coming to microwave region, where some cellular communication, cellular and Wi-Fi communication is established. Further, some cordless phone and landline phones operate in this region, microwave region, which is around 6 gigahertz or microwaves region. Also, microwave oven are there, which works in that frequency range only. That's why it is named as a microwave oven. Then we are having the visible light, which is in between the infrared as well as the ultraviolet. That's why it is here we are having sunlight as the image corresponding to that. Infrared is where we know that x-rays having infrared waves, and then visible, which is nothing but a Vibgyor, which humans can see, and then ultraviolet is something which can ionize the ions. That's why it is preferred that ultraviolet rays are harmful for mankind, because it can increase our temperature, by which means that ions started ionizing. That's why here it is written that as soon as we go up to the high frequency, the ions can start ionizing itself only. So in case of non-ionizing, we have to use external uh, device or external means to ionize the ions in that frequency range. And exahertz, which is the most high frequency considered in the electromagnetic spectrum, is considered the gamma rays, something is which is associated with this nuclear fission and fusion. And that's why it is written as radioactive sources. And medical x-rays are also in the very high frequency range, and that's why in the terms of medical, that's why it is I have said that x-rays and MRI are most harmful for humankind. So the latest cellular communication or the generation we are coming is of 5G, in which we are working in between the 30 to 300 gigahertz frequency range, having wavelength up to 1 centimeter basically. I will also cover some introduction of 5G in the end of this course, along with this MIMO antenna. So these frequency range, like I suppose CDMA, code division multiple access, it operates basically less than 1 gigahertz, and GSM and GSM mobile communication, which comes around 2G and 3G, which is GSM 900 and GSM 1800 band as well. So basically, all the technologies are specified within certain frequency range in which other application cannot be operated. There are some exceptions as well in that case as well, such as 3.5 gigahertz is also allocated for 5G sub gigahertz communication, and same place, and in some cases sub gigahertz communication it is also allocated, and further it was allocated for some other application, and now it is freed by ITU, which stands for International Telecommunication Union, and FCC, that which means Federal Communication Commission. These two international bodies introduce and allocates the frequency band for different ranges of application. Now, these frequency ranges have some names associated with it, because in order to scientifically identified or recognized, these bands have given some names, and these are associated like that. Frequency band designation. So L band is associated with this 1 to 2 gigahertz, then S band, C, X band, which is associated with 8 to 12 gigahertz. X band is most used in case of horn antennas, and C band is also consists of 4 to 8 gigahertz, and S band 2 to 4 gigahertz. Now the further above 12 gigahertz, we are having Ku band or K band, and then Ka band, which stands for Ka band, which goes up to 26 to 40 gigahertz, and U band, which is 4 to 6 40 to 60 gigahertz. And these names are conventional names. However, new names have also been associated and have been started in academic courses as well. You may search for that as well. Here only I have mentioned conventional band designation for frequency ranges. After that, this U band is also come U band as well as Ka band also comes in the millimeter wave band, and 6 gigahertz sorry 6G communication is also there, which supposed to be lying in terahertz band, which is further more higher frequency in comparative to the 5G communication. So whatever the applications are there, like GSM 900, GSM 1800, 3G, 4G, everywhere, technology or the specification have some defined frequency ranges to operate for the. So these are there, which CDMA is nothing but code division multiple access. Earlier I have also abbreviated for it, which operates in the range of 824 to 890 megahertz, which is less than 1 gigahertz, coming in ultra high frequency or very ultra high frequency range. And then GSM 900 is there, which is 8 which operates at 890 to 915 megahertz, and further 935 to 960, and which is coming with then further GPS is there, which is global position system, which operates in L band basically, which around 1575 megahertz, and then followed by GSM 1800, 3G, 4G, 5 Wi-Fi, and also satellite and defense communication have separate frequency range, which is not allocated to other applications. So because of the privacy as well as the security issues. Note that these frequency ranges which I have defined is basically internationally defined ranges, but country to country it may vary. Now further, you may wonder, since satellite and defense communication is already having a high frequency to millimeter wave, so how the 5G will get the frequency band allocation? But In the frequency, I will say that in the electromagnetic spectrum, there are bands which are not used basically and are vacant. So these small bands is utilized for several applications in that particular range. So the frequency is basically allocated for 5G are various bands, basically 26.5 gigahertz to 28 gigahertz, and then 36 gigahertz to some 39 gigahertz around, and then there are bands in 60 gigahertz as well as 80 gigahertz band which are allocated for 5G. So as we go further in the higher in the frequency range, the wavelength will be shorter, and hence the communication will be more complex and more short distance it will be. So for high frequencies like 80 gigahertz, we can use that communication within the room so that traveling of waves will not be so complex. Such as within the room, if we want to make a server for a high frequency and for a high speed rate, we can use 80 gigahertz, which will be within the room only, and other server cannot be access it. Though in the higher frequencies, since wavelengths are very short, so the destroy of signal is very much possible, I will say. Means since the wavelengths are very shorter, the message signal can easily be destroyed by natural means or artificial means. These waves, because of their small characteristics, get easily be destroyed totally even. So because of that, high frequency range are more preferable for within the region, within the building, within the floor. It is more preferable for high frequency. Lower frequencies such as 20 gigahertz, 28 gigahertz, it is maybe preferred for within the region, within some kilometer distance. It can be preferred, and because of the hardware like towers, more number of towers are required in order to increase the distance so that the signals which are transmitted can be easily be transmitted to the receiver side, and therefore in order to amplify that each that signal at each and every stage we need to install the tower so that long distance communication can be accomplished. Further, I will be covering more of 5G in the end, as I have already said. Now in the next lecture I will be covering what is how this antenna operates, what is the mechanism of the radiation, or what radiation means basically. Till now we have covered the applications and so on definitions, but we haven't seen the working of antenna, how the fields have been generated, how the electrical device reduces the radio waves, and how it is transmitted by the antenna basically. Thank you.